So my talk today is called Zen and the Art of Convincing Your Company to Use Rust. There are some hand-drawn illustrations, as you can see right here. I'm going to talk a little bit about NPM, and if you don't know, the NPM mascot is a wombat. So that is the wombat here on a motorcycle, and then the Rust mascot is a crab named Ferris. If you want to know the puns behind that, I'll explain them to you later. They are extensive. My name is Ashley Williams. You may know me from the internet as AG Dubs. If you follow me on Twitter, I'm sorry. If you don't, follow at your own risk. So I currently work as a contractor for Mozilla, and I work on the Rust programming language. So this is a small set of the titles that I hold, because it turns out that an open source project is very similar to a small startup, and trying to do just one thing is incredibly difficult. So at the speakers dinner, I realized that I don't really know the makeup of the audience, so I kind of wanted to poll to get a sense of what people do. So how many people here write Rust? How many people here want to write Rust? All right, hopefully by the end I may have convinced a couple more of you. If you don't want to write it, I'm very curious why you're here. This will be fun. How many people here write JavaScript? All right, cool. There's a small bit at the end about using Rust to make your JavaScript awesome, so I'm really excited to talk about that as well. All right, so this talk today is my story about getting the company NPM, you may have heard of it, to use Rust. And so NPM, as we all know, stands for Nearly Perfect Machine. It definitely doesn't go down or have problems, right? We'll talk about some of those problems later today. But I worked at NPM up until January of this year, when I got to leave that company so that I could do my dream job, which is work full-time in open source. So when I was doing that, I also held a bunch of different titles, and so I still hold some of these today, some of them not. But when you get involved in open source, everyone wants you to do everything, and I'm incredibly bad at saying no. So this is just a set of the things that I've also done. But what you might notice is that in my list of Rust activities, I also happen to manage the package manager for Rust. The CLI tool is called Cargo, and it's awesome, and the registry is called Crates.io. And so I am just, part of this team of really cute animals moving packages of code around. I joke that when I retire, I'm going to work at UPS, which is the parcel system for the United States, because it's simply my only skill set. But yeah, so if you don't know about NPM, NPM always likes to talk about how large their numbers are. So this was taken earlier today. It's funny because when I gave this talk, a version of this talk about a year ago, the numbers were about 50% of these. So big numbers are big. NPM is a huge ecosystem. And so this is module counts. If you don't know about this, this is a site that aggregates all of the packages in all of the different package registries. And I like this because, as you can see, NPM has this thing in startup terms called a hockey stick curve. I don't know why they call it that. It's just an exponential curve. But clearly you can see it's quite large. And hilariously, if you take a look, the yellow line is Crates.io. So we're not quite at the same scale yet. But I show these to say that NPM is the largest package registry in the world. And immediately upon saying this, all of the YouTube comments I get are like, actually no. And so if you want to fight about this, YouTube comments exist, I guess. That's probably the best place to do it. Mostly what I want to say is this is an incredibly large service that has to deal with a lot of requests. And so that's going to be a big reason that we end up talking about Rust. So in 2016, so almost 2 years ago, I got to make this amazing pull request that said add NPM to the Friends page. For those of you who don't know, on the Rustlang website, all of the companies that use Rust in production, there's a lot of blockchain companies, lots of small ones, but there's also some big ones. And in December of 2016, I got to add NPM to that list. And that was amazing. How many people here have tried to get their company to take a bet on a brand new kind of edgy technology? How many people succeeded? All right, so that's good. But if you want to succeed, that's really the goal of the talk today. So NPM uses Rust, and this was like my most exciting thing. I was incredibly happy about this. But I realized that many people in this room may not know what Rust is. So I'm not going to go into too many technical details about Rust. If you want to ask those in the questions, I'm super happy to answer them. But to start, we can talk with how Rust describes itself on its website. Rust says that it is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. Now, that sounds, I guess, kind of good, but most people who hear this kind of hear this. It's like, okay, what? Like, what is systems programming? Every time I ask someone, they have a different answer. And so I like to kind of tell the story of Rust. So many people don't realize that Rust was a programming language that was originally designed to replace C++ in the Firefox codebase. The Firefox codebase needed to move very quickly, at the speed of the web, perhaps. And it turned out that the C++ they had was just incredibly hard to maintain, particularly because of the lack of safety guarantees. Trying to refactor or change something in the codebase could cause really huge problems in another spot. How many people here have ever written some C++? How many people here have written unsafe C++? All the hands should still be up, okay? But that's not to say that C++ is a bad language. It's incredibly powerful. But Rust was conceived to be like, okay, we need to have a C++ code base that's going to be old, and we need to be able to move quickly on it. And that was the original inspiration for Rust. So if many people here have heard of kind of the battle between Rust and Go, that's kind of an artificial one that's kind of developed and emerged out of the community. Like originally, we were really looking to replace C++. So a couple of the characteristics of the language are we are statically typed. It's a compiled language. We don't have any runtime. There's a lot of different ways to talk about types of garbage collection. Some people like to say you have to manually manage memory in Rust. That is not entirely accurate, but there's certainly nothing happening at runtime with that memory management. As a result, the Rust programs that you write are going to have an incredibly small memory footprint. And more importantly, we have memory safety guarantees. And I'll talk about that in a little while. So my favorite way to define Rust is that Rust is a programming language that wants to empower all developers to be systems developers, which is to say, maybe you're writing JavaScript, maybe you're writing PHP, and you're like, I just do stuff on the web, I don't want to get close to the metal. And Rust is here to say, not only can you, but you should. And this is the type of language that you can do that with. So Rust has always been kind of looking at these ideas of trade-offs. And whenever we talk about programming tools, we often talk about trade-offs. But what Rust wants to do is say some of these original kind of baked-in trade-offs that we kind of take for granted, what if we didn't? What if we could say, oh, there's often a separation between the idea of speed or safety and then productivity and ergonomics. And we're like, what if, with the magic of compilers are so cool, with the magic of compilers, we can not have to make this a trade-off? What if we can have all three? Now, Rust is a very new language to a certain extent, especially compared to a lot of the languages people are writing here. But we are working very hard towards this goal, and we've seen a lot of success. So today, I want to more particularly talk to you about the idea of how to convince your company to use Rust. So we're going to step a little bit away from the technical definition of what Rust is, and talk about how you can convince your company to do this. That being said, if you are already decided after my little spiel about Rust that Rust doesn't seem like the thing for you, one, that's cool. But two, I think a lot of the tips here are going to help you advocate for any type of technology you'd like at your company. So you may or may not have recognized that my title is a reference to a book called Zen and the Art of Motorcycle Maintenance, hence that weird illustration of a motorcycle at the beginning. But in that book, there's a statement that says, the number of rational hypotheses that can explain any given phenomena is infinite. So the real answer is, how can you convince your company to use Rust? There's probably an infinite number of answers. But today, I'm going to represent 10 of them. And you may or may not notice that a lot of them have contradictions, because it turns out that things are difficult. So yeah, let's get started. So the very first tip for getting your company to write Rust is to not rewrite your software in Rust. Right? You're like, what? No. So what I mean to say is that you should not completely rewrite your software in Rust. And this is incredibly important. So it turns out that complete rewrites are often very unsuccessful. How many people here have tried to endeavor on a complete rewrite that didn't work out? Yeah. Same. So one of the neat ways to talk about this is actually from somebody who does systems engineering, but also is a pediatrician. He wrote a book called Systemantics about how systems succeed, but particularly how systems fail. And here's what he says about systems. He says, a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a simple system. And so with this quote, you might ask, oh gosh, all efforts will fail. How can I possibly introduce a new technology at my company? And so when I was working at NPM, our CTO is named CJ Silverio, and she gives a talk called Cheating Gall's Law. How can we cheat this idea that we always have to start with a simple system? And this is kind of how we do it. So this is exactly how we do it at NPM, which is to say NPM originally started as a monolith. Even worse, it was a monolith that was basically all inside a database. Recommendation, don't do that. But it turns out that to get NPM started, it was a pretty good idea. So as NPM grew and had tons of scaling problems, if anyone was trying to do JavaScript in like 2010, 11, NPM was kind of on fire. And so the way we started dealing with this was instead of trying to completely rewrite it from scratch, which I think we can all agree was probably going to be a bad idea, we started introducing a proxy and like splitting off tiny little services. And so these are well known as microservices. And so this is like a hot term, and I probably do not have to explain it to you. But it turns out that if you want to introduce a new technology at your company, a microservices architecture is a great way to do it. So to follow up with this, tip 2 is to show up with code. So inevitably, this means that you might be working kind of like off hours, late at night, sneaking in some work to do. And so the very first Rust code that I ever wrote was using this framework called Tokyo, which, if anybody here is familiar with Rust, this is our async solution. And when I was doing this in 2015, it turns out that this was really an immature library. And so the story today around async in Rust is still pretty complicated, but back in the day, it was even worse. But I don't know, I like a challenge. And so I was like, now that we have async in Rust, that sounds like a great replacement for Node. So we've got a bunch of Node. The Node's not working so great. Let me try this out in Rust. So how many people here have heard of a registry follower? All right. So the NPM registry takes in all of these events and sends them out. And you can write a follower to follow these events and do activities. And I'll talk a little bit about that more later. But this was what I decided to do, because fundamentally, this is how all of the NPM registry architecture works. So when I talked about that database, our database application was all inside CouchDB, which is a red couch. That's their logo. And so you can see that all of these types of events come into the CouchDB. And then what we're able to do in the NPM registry is have followers that can follow those events. And so in a little bit less illustrative terms, this is kind of what that looks like, which is to say changes go into the registry emits events, and those followers subscribe to those events, and based on particular data in those events, we're able to do a wide range of things. This is literally how everything in the NPM registry works, and if you ever want to do fun stuff with registry data, this is how you do it. It's much better than actually downloading the entire NPM registry, which at this point is incredibly large. So what I decided to do was write one of these followers, and so this is what my code looked like. It's kind of amazing how pithy it is, but this is leveraging, that's the endpoint, the replicate.npmjs.com/_changes, and all this code does right here is pull in the changes and then print them out to the screen. But that's all I needed to really be able to demonstrate to say that Rust is ready to be able to be part of our architecture. And so here, this adds a little bit more. This is the JS that you write to do the same thing. So this is the Node, and that's the Rust. It turns out that the Rust is shorter, which blew my mind. All right, so showing up with that code was really, really good, but one of the more key things about being a developer advocate is to not sell. What, right? So when I originally came into NPM, our CTO had been looking at Go. She was really excited about Go. Go is an incredibly exciting language. And so if I had walked in and been like, CJ, Go, they don't even have generics. It's terrible. That's a really niche Go joke. Sorry. But as you can see, bashing other languages makes everyone look bad. So unfortunately, oftentimes when you're working in programming languages, a lot of people see it as a zero-sum game, which is to say, if this language is good, that must mean that all other languages are bad. Now, potentially you can believe that in your heart of hearts, but it turns out that if you want to actually change someone's mind, that is a terrible, terrible route to go. And so I see a lot of people being a bit quiet here. I guess that's because I am giving a talk. But this is a huge thing that I see in the community, and it's incredibly difficult to actually convince people not to do this. But beyond that, one of the other things that I think is very interesting about introducing a new technology to people is that you don't have to control someone else's first experience of Rust. And that means you as someone who is selling it, but also the Rust language and its tools in general. So I have a small story about telling CJ and going through this project with her. So what I learned is that not everyone is going to love everything about Rust right away. They'll warm up to it. And so this is some fun punctuation incantation. If you don't know Rust, you don't have to worry too much. But this is something that you can put at the top of your code, which is to say, I don't want the compiler to warn me about how I'm naming my functions and variables. And so it turned out that CJ is somebody who has a very particular style. And to get her to enjoy Rust, I needed to make sure that she could just use that style for now. She really just wanted to use that style. And she was like, Ashley, how do I turn off these compiler warnings? How do I do it? And I was like, oh, I'm sure there's a way. Let me find out. And so I was looking through the docs, and I was like, oh, no. The way you turn off the compiler warnings is I have to tell my CTO that she has to write allow bad style in her code. And I'm like, oh, dang, this is not going to work so great. That's pretty mean. And so I did, and she was like, are you serious? And I was like, I am serious. And that was a bummer. And so when I gave this talk about 2 years ago, somebody saw it, and they actually opened up a PR on Rust, or this is an issue, but in our RFCs repo to say, hey, maybe we could be like a little less shamey about having this. Like having good style if you're just starting out, like we want people to use Rust. So telling them that they have to be shamed constantly is probably not a great way to convince them to use it. Now you might note those GitHub reactions, huh? How about that? So in the Rust community, we work very hard to be welcoming, but old habits die hard with a lot of people. And so this thread became very contentious, extremely contentious. You can see a lot of moderation actions here. I show this just to point out that despite the fact that it was incredibly contentious, Rust values being inclusive and welcoming to new people. We won't succeed if people don't use Rust. And so we have a strong moderation team that kind of shut that all down. And so you can see so many comments happened. But fundamentally, we ended up getting this into the language. So if you want to try Rust, you can name your functions whatever you want, and you can say allow non-standard style and still feel good about yourself. So in complete contrast to tip number 3, tip number 4 is to sell, sell, sell. So in Rust, because we're a new language, we have so many enthusiastic beginners. You may or may not have seen on orange websites the idea of the Rust Evangelism Strike Force. We're upset about that. We don't love that. It's a little bit aggressive. That being said, there are really awesome ways to sell stuff inside of your company that are not aggressive. It's like going around and filing an issue on every repo of every open source project you use and say, please rewrite this in Rust. Don't do that, please. And I'm not exaggerating. There are people who do it, and it's incredibly frustrating to everybody in leadership in Rust. But one thing that I did at NPM to make this work out was we created a React-G channeler, which is something we use Slack at NPM. And so every time somebody shared something, depending on whatever channel it was in, you could react with a crab emoji right here, and it would pull everything into a single channel. So if you wanted to know all of the interesting, weird bits that people were sharing about Rust at NPM, you could hit that crab emoji, and then it would pull up all of the stuff that did that. And just simply sharing things that were cool, like You can see here in this, like CJ was just doing some research and she was like, whoa, there's libsodium bindings for Rust and it's super fast, that's amazing. And so she was able to share that, and then we could index that all so that everybody who was working in the company, no matter what their role was, could check out what those things were and kind of slowly get excited on their own. So, on to tip number 5. So the hard part of programming isn't programming. All right, maybe we all agree on this. But this is a thing that Rust really cares about. And it turns out that in selling Rust to CJ, the thing that really convinced her over Go was all of the support elements that Rust had. So we have a really large documentation culture. We have tons of books. This is not even all of them. One of the things that we've done this year is work to create what we call the domain working group books. The Rust book that we have is very much focused on beginners, and then we have something called the GOTOcon, which is literally like the dark arts of Rust, which use lots of unsafe and very funky things. But we kind of noticed that the intermediate level kind of was missing. And so what we did this year was create domain working groups focused on specific elements of programming that an intermediate developer would be interested in. So we focused on CLI tools, embedded, WebAssembly, and networking. And each one of those groups produced its own book. So we're setting you up to be able to read the Rust book first. Then we've got another book right lined up for you. And then we also have, you know, when you really want to go deep, the really advanced one. And we think that documentation strategy is really, really important. In addition to documentation, we care a lot about tooling. So especially as coming in as a C++ replacement, a 21st century C++ replacement, one of the things that we really wanted to have was a top-tier package management system. And so as you can see here, we have Cargo and Crates.io, but we have so much more than that. So if you happen to use Node or maybe something like Ruby, you've probably had to deal with version manager tools before. And those version manager tools kind of like are weird community side projects, and it's kind of hard to tell which one is the right one to use at a given time. In Rust, we were like, we're just going to do this out the back. So we have Rust up, and that's how you manage all of your toolchain versioning. Additionally, a lot of people don't know that Rust actually has documentation tools out of the bag. So you can use a documentation comment, which is 3 slashes, and then run Rust doc on your project, and it will completely generate HTML documentation for you. So no need to add a separate library, that's just baked in. And this is because we generally want to make the things that are good to do easy. Additionally, if you come from JavaScript, you're probably used to code formatters. You're also used to people fighting viciously about code formatters. Rust comes with one out of the box. It's called Rust format. If you want to, you can configure it, but the defaults are pretty good. And then lastly, if you happen to ever use Microsoft Word, you might get the reference of this idea of Clippy. Clippy is a way to lint your project, not for style or for safety, which our compiler just already does. Clippy will help you write idiomatic Rust. So it does static analysis on your project and is able to say, hey, you're doing this, but did you know that the better way to do it is this? Seems like you're writing an if statement. It would be really great if, I don't know, people were joking when GitHub got acquired by Microsoft that, oh my God, GitHub is going to have Clippy now. And I kind of was like, Rust does have Clippy, is that bad? But Clippy is one of the most awesome tools ever, and especially if you're getting started, again, it's like having somebody else programming with you to check those things out. Lastly, Rust cares a ton about community. So if you're new, we have an IRC channel, which is not an evil, terrible IRC channel, called Rust Beginners that is extremely well staffed by both core team members and community members to answer any of your questions. We are excited when people come with questions about Rust. There's no RTFM there. We really care about it, and we'll happily just sit and work with you through your issues. Additionally, we have started to have a whole bunch of conferences. This is just a small set, but if you are interested in attending a Rust conference, Rust Fest travels all over Europe, and they're really awesome events. Additionally, we care about inclusivity as well. It turns out that systems programming is not the most diverse part of programming, which is not a most diverse anything at the moment. And so we have 2 programs, Increasing Rust's Reach, which is basically our Google Summer of Code. And additionally, we have programs called Rust Bridge, which are educational workshops focused on underrepresented people to get them into Rust. Lastly, if doing kind of problems on your own is your thing, we have a pretty vibrant community over at Exorcism.io, which is a set of code katas that you can do in a ton of different languages, but the Rust one is also there and super great. So I mention all of this, and I know that it kind of seems obvious. You're like, of course, these are good things, right? But you know, despite the fact that they seem so easy and common, they really are neither. It's incredibly difficult to set these types of things up, and I'm really happy that Rust has decided to invest in these things early. Because if you don't get these things early and you try and add them on after, you're going to have a really bad time. And I know this because I participated in Node for a very long time. So getting this stuff out the bat is awesome. A cool kind of fact that many people don't know, the very first commit to Rust was a code of conduct. And a lot of people say, oh, those Rust SJWs, the code of conduct, it's so bad. And they say, I'll never use Rust because of this. And to be honest, we say good. We think it's awesome. All right, so tip 6, the hardest part of programming actually is programming. So of course, when you're trying to sell some sort of tech to your company, you're gonna wanna sell it on technical merits. But I'm not gonna spend too much time here because it turns out that actually selling something on technical merit is very easy. People get very focused on that part and get very distracted and don't focus on the other parts that I personally think are most important. So the only data bit I'll give you here is, for reasons that still kind of baffle me, Rust has been the most loved programming language on the Stack Overflow survey for the last 3 years. Say what you will about surveys, say what you will about Stack Overflow. There is a community of people that really love this language, and that's pretty awesome. All right, so on to tip number 7. So this is going to be a little bit of a vignette, but this is to say, be prepared for things to change. So at NPM, we have a problem that might be familiar to you. We have Node in almost all of our services, and our service logs are not only incredibly huge, imagine us logging all of the events that happen on the registry, but they also have runtime errors, because it turns out that JavaScript has runtime errors. And if you want to be able to go clean those up, you're going to want to look through your logs and parse them. But it turns out that parsing them is incredibly slow. Like, even if you sign up for one of the big fancy services that's incredibly expensive, even then, they're giving you like a service option of like hours, like measuring it in hours. And that's not really going to work for us. And so I was working with one of my colleagues, Ryan Day, and we were really upset about this. Has anyone had a day like this, a week like this? This is PagerDuty going off about every 10 minutes for me on a day while I was working in NPM. Pretty brutal. Always seemed to happen the second I went on duty, like they missed me or something. They're like, pay attention. I'm like, okay, here I am. But this is kind of a huge bummer, and we want to do stuff to change this. So Ryan decided to he was like, I'm going to write a log parser. I'm just going to do it. And so he didn't really know much Rust. He used their documentation and just kind of scripted something up. And he ran into this. He was like, isn't Rust supposed to be super fast? Like, how is my Rust parser 2 times slower than my JavaScript version? Like, this is not what you sold me on. How is this even possible? And so there were several different things, including this. There's a lot of memory management that's happening in Rust. And so how you write Rust fast is actually just a little bit more complicated. And so if you write a naive thing, there's a chance that the thing that you write in Rust is going to be slow. It turned out in this situation, which is a default that we finally changed, thankfully, was that when we were reading in a buffer, the default size of that buffer was different than what the default size of the buffer was in Node. And it turns out that our size was making the buffer read incredibly slow. So when we manually set that to be what was on Node, it sped up to around 3 times faster than the JavaScript. So I think this is a really interesting quote from my colleague, where he said, I just fully expected to rust my way into 50% perf over JS. But sometimes I forget that V8 is pretty darn fast. So while trying to sell Rust over Node, it's again really important to remember bashing other languages doesn't work. Like, other languages are really good. Node is really fast. And so trying to get that speed is not always exactly what you're looking for. So this is another quote from that Art of the Motorcycle Maintenance, and it says, you're never dedicated to something you have complete confidence in. No one is fanatically shouting that the sun is going to rise tomorrow. They know it's going to rise tomorrow. When people are fanatically dedicated to political or religious faiths or tech, maybe, it's always because these dogmas or goals are in doubt. So what that's to say is that when we are kind of promoting these types of things, like, it's because there's a question there. There's an interesting trade-off. There's a potential that's maybe yet unfulfilled. And so something that I found was really interesting is that originally I thought I would be selling Rust because of its speed. But in the end, I really ended up selling Rust because of its safety. And so when you go to promote technologies inside your company, you may go in with particular reasons, but be prepared to react to the other reactions you get and to potentially change those reasons. So even though the learning curve in order to make Rust a bit faster than Node was higher than people initially wanted, the safety guarantees made it worth that. But you have to be prepared. If I had just suddenly seen, oh, it's really hard to make Rust faster than Node, I may have just stopped and been like, maybe this is bad. But paying attention to how people are reacting and being able to say, okay, be ready to change your mind, it can make it a lot easier and a lot more effective. So as I said, there's a learning curve to making Rust go fast. So I told you kind of a sad story about log parsing, but now I'm going to tell you an amazing story about log parsing. So this is Andre Arco. Andre Arco helps maintain Bundler, which is a package manager for Ruby. And similar to our situation in Node, he has a lot of logs. And so he was like, shoot, I really got to figure out how to parse all of these logs. And so originally, he kind of started out using AWS Lambda and Python. And his first attempt ended up costing him around $4,000 in server bills. And he was like, whoops, this is not going to work. And so he started being like, why don't I try out Rust? And so what's really interesting is that when he did end up trying it out with Rust, he got it fast. And then, because he was reading the docs for the library he used, Serde, he was like, oh, here's another library, maybe I should use nom. And so he did it in nom, and it ended up speeding up just a little bit longer, or just a little bit shorter. And then he said he showed it to a friend. And the friend looked at it and went, like he had gone from about, these are the numbers, from about 525 records per second to 50K. And he was like, I'm doing great. This is awesome. He showed it to a buddy. And the buddy was like, how is that so slow? We're going to have to profile this. What is going on? Why is this incredibly slow? And Andre was like, I already sped it up like 200%. Like, what do you mean it's slow? And kind of hilariously, depending on how you're used to things, so Andre comes from something like Ruby where compiler optimizations aren't a thing. He realized that one of the things that he could do was just run cargo build -- release. And that was able to turn on all the compiler optimizations. So he had gotten something that he thought was incredibly fast, and there were still little things to learn about how to make it go even faster. So his current implementation that's in Rust now goes so fast that it fits in the free tier for AWS Lambda. So we went from paying about $5,000 to none, which is incredibly awesome. Yeah, so making Rust correct is the default, right? Making it fast can take a little bit learning, but the best thing about Rust is making it correct is the default. So we like to say in Rust that the safest program is one that doesn't compile at all. And that's because we have a compiler that's going to do a bunch of static analysis on your program, and it's going to tell you a lot of this. No. That's bad. Don't do it. You must change it. And while a lot of people can kind of see working through compiler errors as something that's really tough for a beginner, one of my favorite ways is to kind of switch that perspective and say, hey, wouldn't it be awesome to just always have a pair that's incredibly smart and knows how to analyze like race conditions in your program? And they're just there all the time. So Rust compiler has some really amazing error messages now. We have the Elm community to thank for that. If you have ever used Elm, they have absurdly good error messages. And I don't think we're quite there yet, but we are very inspired by what they're doing. But a lot of the time, our compiler can just take a look at your code and just be like, hey, this isn't going to work. Also, here's the exact code you should write to make it work. It's really amazing. The amount of cognitive effort I have to do in writing a program when I write it in Rust is so much lower than the cognitive effort of writing a language, writing in a language that doesn't have these types of guarantees. Turns out that compilers are really amazing. So whenever you're designing a language, hopefully one of your goals is to at least make the right thing easy. We want to encourage people to do the right thing, so we want to make that a happy path. And Rust believes in this too, but Rust also believes that we should make the wrong thing hard, nay, impossible. So again, we will just not compile your program if it's going to have errors. And so to that extent, we're like, nope, just can't do the wrong thing. And as a result, we're able to have programs that are incredibly reliable. So on to tip number 8. So we were being prepared for things to change, but now we need to be prepared for things to stay the same. So boring code is my absolute favorite code. How many people here like boring code? Not enough. Oh, boring code is so great. I really love it. But I understand that lots of people love writing clever code. And particularly when you're excited about a technology, you really just want to start leveraging all of its awesome superpowers. You're like, this is what I want to do. It's kind of funny, when I started writing a lot of my first Rust code, I was like worried that it was not very good. So I talked to some of my friends on the core team, and I'm like, is this like horrible Rust code? And they wouldn't even look at it. And they're like, are you using like a box or an arc or any of that stuff? And I was like, no. And they're like, great. You're probably fine. So reaching for those awesome superpowers of a language can be something that's really attractive. But again, when you're trying to get a company to use it, when like their money is at stake there, writing boring code can be super good. So just because you started using Rust doesn't mean that everything will change in your company. In particular, it's probably a lot better if it doesn't. When you're adding technologies to a company, having something be boring and not a large change is really, really important. So I like to talk about the scientific method here. A lot of people think that it's a thing that I missed the spark thing. I don't know science. But what you want to do is only change one thing at a time so you can actually measure Rust's impact. Using data, data-driven change is kind of a saying that everyone says, but it's actually super important. So this is one of my favorite sets of benchmarks. So this is actually benchmarking Rust-generated WebAssembly, but it is a benchmark for Rust. And so this is when the source map implementation for the Scala.js source map implementation, and that was generated into WebAssembly, so it could be run in the browser. And one of the things that you can see here is we changed just one thing, so it was easy to measure. But what I also want to point out here is that while the Rust-generated WebAssembly is faster, I don't think that's what's the most awesome thing about this graph. The most awesome thing about this graph is how reliable the memory profile is. As somebody who does ops, any ops people in the house? All right. Well, as somebody who does ops, the idea, look at the spread on WebAssembly and Firefox. I think that's that. Oh my goodness, that's terrifying to me. I cannot predict how much that is going to actually take. Whereas if you take a little bit of a look at how that's working in the WebAssembly, it's incredibly small. And that reliability is more important to me, and probably more important to a company, than the actual speed difference. And so, again, being ready to change your mind, being able to measure, and be able to show some of the most awesome things about that is incredibly important. So the other great thing about only changing one thing at a time is that if you change more than one thing at a time, you're probably going to burn a bunch of people out. Having lots of things up in the air can be incredibly stressful. And so even though you are particularly excited about technology doesn't mean that your entire team wants everything to change at once. Sometimes if you're on a deadline, you want to reach for the tool that you're super comfortable with. And so trying to change everything at once is a recipe for failure. So one of these things that we saw at NPM is that, so Rust is a compiled language. We're able to compile into binaries, which is super great. As an ops person, I'm like, perfect, binary, just stick it up there. Boring, I love it. But the team really wasn't ready to set that up yet. We have an incredibly extensive set of YAML files. Again, not many ops people in the house, but if you do ops, all the YAML files, oh my goodness. But we have tons of YAML, and it was kind of a big pain in the butt. And what we realized is that even though Rust is able to generate a binary, for us at that moment, we just needed to deploy the Rust the same way we were deploying the node. So this is how we do it. Again, here's some YAML. It's delightful. But we decided to do the same thing, which is to say we pushed up the source code using a Git hook, and we actually compiled on the server. Was it slow? Yes. Did it not set the whole team on fire and make them enjoy Rust? Absolutely. So moving on, the next tip is to have a problem to solve. Again, there's a lot of solutioneering in technology, and that can be great, but we have so many solutions, and we tend to kind of lose sight of the problems. I saw a tweet that said, solve the problem you have, not the one you want to have. And yet, I see so many people constantly solving the problems that they think are super cool, but not actually the ones that they have. Now, I like to say that finding a problem should be easy because all software is terrible. It really is. I don't know. If you're here and you think computers work, please bring me hope, because my experience throughout software is like, if it works, that's great, but like it probably won't work for long. So, as I told you at NPM, big numbers are big. When I was writing this service that I'm going to talk to you about, we had about 70 billion downloads occur on the service. So that is a lot of traffic. And these are her rolling weekly downloads. They're going straight up. Just for fun, though, you might notice that huge crevasse there. People actually do take vacation on Christmas. It's cool. We literally see it. All of our metrics alerts that are like, your stuff is broken, always ring off during Christmas because people actually stop writing JavaScript. Yay! That's positive. And then they start again. Clearly, they really just pick right back up where they left off. So we have something in NPM called store file transforms, which is to say, when you have a package, you also have a bunch of other stuff associated with the package, like a README and also some metadata. And we need to do processing on this. And so if you're curious about something that Rust is particularly good at, Rust is super good at just processing files, Markdown, all of this. It's super excellent at that. And so we had this kind of similar situation where we'd get changes in, and those changes particularly were publishes. And then what we needed to do was to take a bunch of the metadata and associated files with that publish, and then run a bunch of transforms on those files. And so we were doing this in Node, and it was falling over. The memory problems were terrible. And so you might be like, you're a bad developer. And like, I mean, probably, aren't we all bad developers? But we're pretty, much of the engineering resources at NPM are people who are on the Node TSC and working literally on Node. So we're pretty good, but it turns out that memory is always still a problem. And so what we were able to do is we were able to take that bit, just that one tiny bit. And so if you're wondering, where's the Rust in NPM? The Rust is in the store file transforms. There's actually a couple other auth services, mostly associated with our enterprise product. But the store file transforms are all done in Rust. And that's because they were able to do it, not in necessarily a fancy way. It's faster, but it's not that much faster. What was awesome about it, and what CJ always says is, I like Rust because Rust is boring. We deployed that service 2 years ago, and it has never alerted. It just does what it needs to do. And that's awesome. Again, not super flashy, not the most fancy part of NPM, but it was a solid choice for this one particular problem. And so as you seek to add technologies to your companies, find a problematic part of your product, and then just try rewriting it in Rust. It's kind of a cool experiment, but make sure that it's actually a problem, because solving something that's not a problem, again, is adding a bunch of churn that most people in a company are not interested. Don't make people take on risk they don't need to. Find the parts where you're already having risk and try and alleviate them. So the final tip number 10, is learning curves are a blessing in disguise. How many people have heard that it's hard to learn Rust? All right, I'm here to tell you that many people report that it is incredibly hard to learn Rust. However, one of the things that you have to manage at a company is employee motivation. And so this is my colleague Ryan, who was working through that, kind of weird log parser he was writing. And what he said is, this is the really fun part about learning new things. I still have the patience to do any number of silly things. And so that's kind of adding a joy. And so we all kind of slave away writing the code for the money. And the opportunity to learn something, particularly something hard, can be really great. It's energizing. And it often can be energizing if it seems particularly challenging in a way that's going to expand what you understand. If we go back to the idea that what Rust wants to do is to make everyone a systems developer, bringing Rust to a company where people are not known to be systems developers can not only, help them learn a new technology, but open up a whole new area of technology for them to become excited about. So, in summary, these are all your lovely tips. Apply them all at once and enjoy the pleasure of contradictions. So, to end, I'll say, if you're going to repair a motorcycle, an adequate supply of gumption is the first and most important tool. If you haven't got that, you might as well gather up all the other tools and put them away, because they won't do you any good. So, gumption here is, the definition is a spirited initiative, but also resourcefulness. Being really enthusiastic and shouting from the rooftops that you love a technology is great, but it is not enough. You have to add an understanding of context and an openness to understanding other people's experiences in order to be able to do it well. So what I'll say is please go forth and try Rust. I hope I encourage some of you to be excited about it. But my final thing is a plug for the project that I'm currently working on, and this is because if you have any client-side component of your application, which means you're running it in the browser, this whole idea of taking a tiny part and trying to use Rust to make it faster or more reliable is something that we are working on in the Rust community to make WebAssembly do. So you can take Rust and compile it to WebAssembly and be able to plug it just directly into some browser code or some node code. If you're interested in that tool, this is the tool I work on right now. It's called WasmPack. If you like the crab, I have stickers. So go forth and try new things. This is the repo. Thanks so much.